let's talk a little bit about Fusion development. So I really wanted to do that session mainly because I've been involved in quite a lot of work and with a lot of customers that are typically asking for only low-code, no-code, out-of-the-box solutions. And most of the time, I find that we are actually spending more time trying to resolve this no-code, low-code solution rather than actually get the benefit of those platforms. So now I'm going to give you a twist on that story and say how Fusion development, as in introducing a little bit of customization, can actually enhance that low-code, no-code experience and take you to the next level. And this is based on personal experience, on something that I've tried with a customer. I'm not going to name the customer, but I'm going to replace them with a fictional customer, an insurance company. But the solution is typically the same. So quickly, a little bit about me. So you guys know me. I'm Rami. I run the Wellington user group. I work for DXC, and I'm an MVP based in Wellington. So a lot of my customers are in the public sector. So I hear a lot of similar requirements as I go from one customer to the other. Quite often, they say, oh, our systems are very specific and they're very special to us, and we do this and we do that. I'm like, okay, what I'm hearing is that you've got an application that comes in, you process the application, you make a decision, you get an approval, and you issue something. And everybody has the exact same process. And I'm like, okay, well, let's see how we can turn that into a configurable framework with a little bit of customization to do exactly what you guys want so that we can turn it into a cookie cutter approach and deliver for other customers. So the theme and the most important thing that I want you to get out of this session is this. If you want success, embrace Fusion development. Understand it, and then get the most out of it. So starting with what is Fusion development? So someone mentioned, I think it was Lynn or someone else, Bernie, he mentioned Scott Duro. Scott Duro, in my opinion, is the #1 MVP of all the other MVPs. Or if he's not #1, he's in the top 3 at least. He's done a phenomenal amount of work. Microsoft, the product team themselves, asked him to come into Microsoft to solve their problems because he's been in the industry for a while. He knows the product inside out. He's the guy. First of all, he was my support when I wrote my book. So he wrote the foreword in the book. He's the guy that built the Ribbon Workbench. And in fact, the new Ribbon in Dynamics 365 and Power Platform is mainly done by him. So Microsoft hired him to go and get some hints on how best to do it. They got some ideas, and then they built it. So brilliant guy, really nice to talk to, really down to earth and lovely. And he came up with a hashtag ProCode, NoCode Unite. And basically, this is saying that rather than always fighting functionals with technicals, saying, no, let's do it the functional way, let's do it the technical way, let's do it with JavaScript, let's do it with PowerFX. Why don't those two teams talk to each other and collaborate? Understand the strength of each one of those teams and try to get the most out of it. So for the purpose of this presentation, I'm going to put it in the context of an insurance company where you might have a specific set of rules that will allow you to auto-approve an application or to go through a manual approval process where they would require some more information. So the 3 rules that I'm going to introduce is if a claim is less than $1,000 or $2,000 or $3,000, $5,000, whatever it is, auto-approve it. So just allow it to go straight through. If the claim is less than $5,000 and it's a premium customer, then you can also auto-approve it. That's not a problem. However, anything else just goes through a manual approval process. So larger than $1,000 for a normal customer or larger than $5,000 for a premium customer. So when we looked at introducing rules into our environment, we realized that we had quite a few challenges. So there's a few examples where I went in and I inherited the project or a project that we built where the customer said, that's it, absolutely zero customization required in there. You've got Power Automate, you've got out-of-the-box workflows, you've got Power FX, do everything using those. So we went there and then we started either building it using their requirements or their direction, or we inherited it from somewhere else. And then we realized that it was a bit difficult to maintain. So here are some of the challenges. The first one is that the rules were scattered everywhere, right? So there's so many different ways that you can do it. You can put rules in Power Automate. You can put rules in Power FX. You can put rules in Canvas app if you really want to. So we wanted to move away from scattering it everywhere and then putting it in one central location. Some rules were hard-coded. So we didn't have the flexibility of introducing a variable. So today it's $1,000 and $5,000. Tomorrow it's going to be $2,000 and $10,000. How do we parameterize that to make sure that it's a little bit more flexible? Then on top of that is, going through something like Power Automate, where everything is in a big, massive Power Automate with if statements and switch statements and all of that. Understanding where that rule is in the code is difficult. That maintenance aspect, tends to be quite complex, especially as you've got many rules. You would want to know, or where did I do this one? Which branch is it? Which switch statement you have to expand, you have to close, and then you go and find it. If you're doing Canvas, it might be behind a control. Go and find that control. Go and do a search in the source code to understand where that is. So in other terms, complexity ramps up with the number of rules, even if they're simple. And then we had some high-level requirements that we wanted to address, that we want a centralized location to go where those rules can go. So other than, rather than having them scattered, let's have them centralized. Let's empower power users, citizen developers, to be able to go and edit those. So if you put it behind a Power Automate, maybe if they're brave enough, they can go and have a look at it. If you put it under Canvas, Power FX starts to become a little bit more difficult. So we wanted to empower users to go and change it, to have the keys to do it, and to do it in a very easy way. And also, once it's done, and usually I work with enterprise organizations, we want to embrace the solution development lifecycle, where you can go through different environments and migrate those rules from one environment to the other, and then get them through the test environment, user acceptance, pre-prod, prod, and so on. And then we had some non-functional requirements, such as, they need to be somewhere in the cloud, so a SaaS solution. We wanted to ensure that they are in the near shore. So quite a lot of government departments will say, I don't want something hosted in the US. And that straight away rules out some SaaS products that are available globally, but not necessarily in the Australian or New Zealand data centers. And then they wanted it to be stateless. So as rules trigger, you don't want to leave a trace behind so that people can't see what triggered and what didn't trigger for privacy purposes. And then also they wanted a certain level of sort of performance and security, just to make sure everything is working as expected. And most importantly, ensure that there is disaster recovery solution, so that if the system goes down, then at least we know either that we are notified or we know that there is a backup solution. So we had a look at a few options. As I said, first of all, we looked at Power Automate. Love Power Automate. There's a lot you can do. Undeniably one of the best sort of low-code solutions that I've worked with. But in terms of maintenance, like when you start going into, for each loops, switch statements, conditions, nested conditions, and all of that, very quickly, it can become difficult to maintain. And this is changing. This is improving over time. So Microsoft recognizes that there might be some challenges with difficult Power Automate. But let's say you've got 1,000 rules. Would you have 1,000 switch statements or 1,000 nested ifs and elses? And I've seen that in Power Automate. So like, wow, even Microsoft goes, oh, we've seen this worst case scenario, and it was a nightmare. And people take it and do things with it that they're not supposed to be doing with it. So it's something to keep in mind and to consider. The other thing about Power Automate is that, and that has improved drastically recently, is that the time it takes to execute. So if you're executing something in memory, it's super fast. So if you're not, let's say, doing a connection to a database or something like that, you're executing in milliseconds. If you have, let's say, a transformation, so you take an input, you transform it, and then you take it out very quick. However, keep in mind that this is an asynchronous process. So for the asynchronous process to wake up and to execute and then to return an answer, that takes a little bit of time to be done. The moment you start introducing read statements and connections to databases, then we're talking about seconds rather than milliseconds. So it starts going up a little bit. And then those are relatively simple executions. So you can imagine that if something really, really complex, then you're talking about multiple seconds to execute. Cool. Now, we also had a look at, we said, okay, maybe Power Automate is not the best solution. Let's have a look at what else is in the market. So we started looking at the competition. And then we came across four very famous ones. So obviously, Power Automate, North 52, which is one of the most talked about rules engine associated with Dynamics 365. So in a nutshell, North 52 is embedded within Dataverse, within Dynamics 365. So the rule authoring experience happens in there. The good thing about Node 52 is that that same rule that you create within Dynamics 365 can be applied onto your model-driven app, onto your Canvas app, onto the portals, Power Pages. So you can define your rule once and reuse it multiple times. You can use it for validation, for calculations, for many different things. So it's quite powerful and very famous. NRule is slightly different. NRule is primarily a rules engine as opposed to a Dynamics 365 or a Dataverse rules engine. NRule sits outside of Dynamics, so it needs its own Azure infrastructure. But the good thing about NRule is that it has out-of-the-box connectors to Dynamics 365. It requires a little bit of setup, a little bit of connections and so on, but it's quite a powerful and popular rules engine. The last one is FICO, very popular in the financial industry. No connections whatsoever to Dynamics 365, so you'll have to build it from scratch. It's possible, but you have to build it. So we did pros and cons. I'm just going to highlight some of the cons that we've identified. For Power Automate, it was mainly difficult to maintain, as I mentioned in the past. And it's not necessarily a rules engine. It's an automation engine. And because of that, it makes it difficult to implement a large volume of rules. Node 52 comes at a cost. So you have to pay for the licenses. It's not cheap. But also at the same time, it generates a lot of things that are difficult to manage. So for example, if you're doing a rule that is going to be used on a model-driven app, then it generates JavaScript. And if you have a governance process where you have to go and review that JavaScript, you don't know what's being generated. You don't have control over it if you don't like it. So it's basically we're at their mercy. And especially when it comes to Power Pages and portals and public-facing stuff, you don't want to have auto-generated JavaScript to do the logic in there. NRule, as I said, connects to Dataverse, but again, it needs all of the infrastructure that comes with it and so on. And given that it's actually extracted from Dataverse and Dynamics, it runs into its own environment, it is slow. Similarly to FICO. FICO is hosted outside and also has some complex pattern to connect to it because the connectors are not available out of the box. So with all of that, we thought, all right, we'll scratch all of that. Let's put our thinking hats on and let's see what we can do with the platform that we've got, with the team that we've got. Which brought us to what the customer said. We want everything out of the box, low code, absolutely no customization. So we thought, all right, let's say this is our work distribution pattern per sprint. So that's what the title says at the top. You can't see it. But we basically have one sprint, 3 weeks, 10 people, right? So 3 weeks, 40 hours per week, 3 weeks, 120 hours. And then multiply that by 10 people. So that's 1,200 hours that we've got within a sprint. And we've got people that can do customization, people that can do configuration, and people that can do data management. So we had a look at what that work distribution would look like when we put it into something like Azure DevOps or Jira. And we realized that based on what the customer is asking, they want everything to be done in configuration, very little to no customization whatsoever, and not much to do in the data space. And we're like, okay, well, we know it's difficult to find people in the market. People that are doing customization, yeah, they can do configuration, but if you want to keep them engaged, give them something challenging to work on and to have fun with. So the balance doesn't look right. So I'm like, okay, well, let's see how we can maybe, by spending more time in customization, lower the amount of time that we do in configuration and ensure that we also have things that are data-driven. And this is what our workload actually looks like. So we tripled the number of customization that we do from 100 hours to 300 hours per sprint. We lowered the configuration from 1,000 hours to 400 hours, and then we doubled the amount of time we spend in data to 200 hours. So all in all, we saved 300 hours per sprint. We can either use that as contingency, or we can go and sip pina coladas and bars and enjoy our free time. But the idea behind it is that let's do a balanced sort of approach, and let's see how we can add a little bit of configuration to make the rest of our lives easier. So the first thing we had to do is come up with an approach of how to build that framework. And that's a really important thing. So first of all, evaluate the feasibility of building it. So understand what is available in the market, do our research, and understand how much effort we have to put into building that. To ensure that the customer understands the direction that we're taking and the customer is on board. Because if you go and tell the customer, oh, by the way, I'm doing a little bit of customization, and they go, oh, no, 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 absolutely no customization, and you go live with customization, you're not going to be in a good situation. And in fact, when I was talking to Annie and Kiri earlier, I asked them that question, like, do you guys know how much customization is in your product? And they said, no, no, it's all out of the box. There is customization, but that customization makes it look like it's out of the box. And this is the beauty of it, is just to make sure that the customer is on board. Now that the customer is on board, make sure that your team is on board as well, because they're going to build it. And if you don't have the technical capability to do it or the know-how, then you've got a little bit of a challenge. And then come up with some guiding principles. What can we do? What can we not do? And that's some of the bits that I'll talk about later. And then make sure that you have also, the testing team is on board. They know what needs to be tested, and it can be tested, stress tested, and scale tested, and so on. So here are some of the, so we came up with the evaluation engine, and we came up with a few principles that we wanted to do. So first of all, we wanted to be accessible through either out-of-the-box connectivity or through external APIs. As per Note 52, we wanted to address it from different angles. So we built that rule once and then be able to call it multiple times. We wanted to leverage as much as possible out-of-the-box basic functionality of the platform. So schema that is out of the box, the tables. I mean, yes, we are going to configure them to do whatever we wanted to do, but we're not going to build a custom database somewhere else that is going to be leveraging that. So keep it within our Dataverse environment and then don't extend it too much beyond that. Make sure that we understand what it can do and what it cannot do. And mainly, don't get it to do difficult things like a custom integration that is specific to a customer or that is really difficult to turn into a cookie cutter approach. And then we also didn't want it to do a lot of calculations and so on. So the engine itself just takes information, takes a rule, puts the two together and comes up with an outcome. It's not responsible for calculating or doing roll-ups or trying to figure out a number. It's just rule in, data in, and then output out. Some more principles that we followed is that ensure that it doesn't have any dependencies, no dependencies on any of the existing components. So as we distributed that to one of our customers, we wanted to make sure that we can lift it and shift it and use it with another customer. So if there are existing components that are specific to that customer, let's not tangle it. Let's keep it loosely coupled. And I'll talk about how we did that. Actually, here you go. Loosely coupled, so the rules, the engine itself doesn't know about the customer schema, doesn't know about the customer's tables. It can be configured to know about it, but I can move it around and put it to another customer, and then that would not be coupled with any of the customer's schema. The rule itself or the engine itself is unaware about the rules at build time. So it knows that it can do comparisons. It can know that it can do outputs, actions based on those comparisons. It come up with, whether it's a match or not a match, but we're not ingraining those rules within the framework itself. We want it to be agnostic of those rules so that we can feed them at runtime. And as I said, it does not require any external infrastructure, so keep it within the boundaries of Dataverse. The last set of principles were more around what we want to do from a development perspective, and I love the solid principles. And I thought we only used 2 of the solid principles. We actually used all 5, which is really great. So S stands for single responsibility, which means that if I want to do something within a class, let's say, or a project, it does that one thing and nothing else. And I'll talk about how we did that. So again, the rules, for example, will take rules and will take data. So there's a class that takes the rules, there's a class that takes the data, and they don't know about each other. They're completely independent. The O is probably one of my favorites. So this is the open-close principle. So it's closed for modification, but open for extension. And as I said, when we deploy it to a customer, it's closed, so it doesn't know about the customer, but it is open for extensions where we can add plugins to it so that it knows about the customer or can do something specific to the customer without soiling the core data. The L stands for the Liskov substitution principle. So this is designed by contract, as in everything that we do follows a specific interface. So it's not specifically something concrete. So today I'm connecting to Dataverse. Tomorrow I'm connecting to SharePoint. All of that can be abstracted. So it follows a contract that doesn't follow something concrete. And this was key to ensure that our code base is unit testable. And I'll talk about unit testing, and it saves us a lot of time. And then I is for the interface segregation. So it should not be dependent on a specific interface that it does not use. So keep things separate, basically. And last one is depend on abstractions, not concretion, so similar to the I that I had in there. All right. So let's see how we did actually the setup and how we actually progressed with the implementation. So in order for it to work, we have to define a set of rules. We have to define the versioning associated with the rules because rules change over time. So we just need to make sure we cater for that. And that includes an effective date on when that rule is going to be available. The second one is to make sure that when we're actually doing a release, that release is primarily data-driven. So remember when we talked about doubling the amount of time we're spending in data. So we wanted the rules to be as simple as records in the database, records in Dataverse, so that we want to move from one environment to the other. All we do is extract that data and then move it to the next location, which means that given that this is part of the SDLC and our DevOps pipelines, we can extract that data into Azure DevOps, into our source code repository. We can secure it in our source code repository, which is quite a secure place if you think about it, because not everybody has access to it. We can limit specific areas where that data is available. And then once it starts going into upper environments, it's completely closed for modification. That reminds me of my days when we were in the Army. Terrible hygiene area. Like, we used to be in the kitchen, we used to see rats running everywhere and all of that, but the food was cleaned. Why was it clean? Is because it was done in big sort of cauldron that are sealed shut the moment they go into the furnace where they get heated up. And again, things are secure basically until you open them. So this is similar to that approach. And again, easy to transport using DevOps with the data platform. Dataverse specifically, we've got lots of tools that help us move data from one environment to the other. So then the next thing is to define what is not in scope. So if we're doing external checks, for example, like identity for checking a passport or someone's driving license and so on, we're not interested in building that into our framework. Again, integration, not our responsibility. Calculations, number of claims, total number of dollar values and all of that. There are other ways of doing it. We don't do that. And then the results should be relatively easy to manage, and they should be able to be executed in memory as well. And I'll talk a little bit about that. So during the execution stage, we basically get the data. We transform that data from something that is in Dataverse into what I like to call a payload. And the payload is basically a bunch of key value pairs, as well as a one-to-many relationships in case we've got an array. Like, for example, number of, or list all the claims, or give me the cost, which is one will be cost, the other one will be $1,000, so key value pairs. Simple things like that. So what we do is we feed the rules and the payload into the engine, and we get the two to come up with the results associated with it. And once we're done with that, then we decide what are we going to do next? So what is our next action? And we had 4 things that we could do. So we can, as simple as update a record. We can go and execute a custom action, and this is where extensions come in. So as I said, we don't want to resolve all the problems in the world, but we can introduce some plugins to actually go and execute some specific actions to the customer. So we did that through plugins, or call a Power Automate or create a task, for example, something as simple as that. So our framework was able to do versioning based on effective dates, value matching, leverage environment variables. So we introduced the out-of-the-box environment variables to feed into those rules. So we can then tweak it in case those values change. Use out-of-the-box security models. So the customers quite often say, we don't want our staff to be able to see what the rules do or what the rules are, so that they can play the system and then put in values so that they get the outcome that they want. So we can use out-of-the-box security model to hide the rules from the end users, and then just keep it as an execution engine. automatically trigger when a specific record gets into a state, and I'll demonstrate that, and also be able to loop through records using fetch XML data and get one-to-many results. It did come with some limitations, though. And again, we couldn't resolve everything, but it was good enough to actually go and deploy it. So in terms of limitations, the one-to-end relationship sometimes got difficult when we had multiple levels that we had to jump through. So we kept it simple, and that was enough for us. The authoring experience was not the greatest, but in terms of priority of things that we wanted to leverage, the authoring experience was neither here or there. And again, I'll talk a little bit about what that looked like in the demo. So that took us to the implementation vision. And in here, we started sort of talking about how we wanted to work. So we had the engine in the middle, right? So it has all the business logic that is required. And at first, the way we designed it is that we're going to build it as a custom plugin into Dataverse. So not necessarily Dynamics 365 thing, but it works in any Dataverse environment. And a plugin, as you guys know, it's basically code written in .NET and C# specifically that executes in a specific part in the execution pipeline. And then that calls the data layer that is available in Dataverse. Again, single responsibility meant that we can say, this is a class, and all that does is understand that there's an entry point, which is a plugin that calls a business logic. It doesn't know about the business logic, it just knows that there's something that needs to call in there. The engine itself is a class or even a project, because it was a little bit more complicated than a class, but it didn't know about the data layer. So today I'm using Dataverse, tomorrow I'm using a mocked data layer coming from a unit test. So there's really a separation of concern, which meant that later on when we wanted to change things and allow it to be called as a custom action, we can just introduce that separately. If you wanted to introduce it outside of a plugin and use it as a custom API, we could also do that. So we would build that interface in here that would call the engine and then call the data layer. And then last and most importantly, if you want to bypass all of that and test the business logic, we can do that using a unit test. So that made it really flexible to test and really flexible to enhance without actually taking too much time in terms of, oh, I've made a change, I upload the plugin, does it work? No, it doesn't work. Go back, make the change, compile, the plugin, does it work, does not work? We can do that using unit tests super fast. So in a nutshell, there is some data configuration that defines what the payload is going to look like. So that data configuration traverses Dataverse, picks up the value that it needs. I want the application type, I want the criteria, turns them into just a text, basically, a JSON object. And the good thing about that is that once I'm out of that data generation, the link between those two is nothing but a file or a JSON representation text that goes in. So when it comes to the evaluation engine, it doesn't know that this is coming from Dataverse, right? So I can mock it, I can do whatever I want with it, I can pass it through an API. Same thing with the rules. So the rules are available in there, and we don't know that they're coming from Dataverse. They turn into the text and they go to the evaluation engine, which means that the engine itself is nothing but C# code that has absolutely no recognition of where the data is coming from and absolutely no connections to Dataverse itself. So, and then once all of that is done, then we get the results at the end. And then those are also plugin types that will say, all right, my next action is to call that Power Automate. So I know that there is a class somewhere in there that knows how to call Power Automate. There's a class that knows how to do a custom action, create a record, and so on. Again, separation of all of that. All it knows is that I've got this instruction to run. So if I change that view in terms of sort of what is customization and what is configuration, so where do the technical team comes in and where does the functional team comes in? So the first part is, getting the record to the right state and so on. That's a mixture of both. Sometimes it's Power Automate, sometimes it's customization APIs, whatever it is. And then that triggers the evaluation engine. The rules are mainly configured data that we have. The payload generation, the data is also configured data that we have to do. And that goes into the evaluation rules. This is mainly customization. The engine itself is the core of what it does. And that needs to be done as customization. And then finally, the triggered actions, if they are something that is, requires a new connection or a new API, then it will be on the customization side.
If it's something that's like calling Power Automate, then or creates a task based on a specific configuration, then that turns into configuration. So as you can see, there is a balance between what is configuration, what is customization. The good news is that even though there is a bit of customization required over time, that diminishes because the platform itself is stable, right? So we don't have any new rule types, if you want, because it can cater for most of them. The actions that are triggered have mainly been implemented. We just need to configure them to do something specific. So the time that we spend on customization goes lower and lower, and then we can focus more on just making sure that we've got the right payloads and the right rules and so on. So from an entity relationship diagram perspective, we had something called a rule group. So the rule group is that, you know, when this record gets into that state and it's of that type, then I know there's a bunch of rules that I need to execute. What are those rules? They're defined in here. And what happens in each one of those rules is what we have in the rule items. So the rule item could be something like the cost must be less than $1,000, or the cost is less than $5,000, and the cost, the type of customer is premium. Those rule up into a rule. When that rule passes or fails based on everything that we've got in there, then it executes one or many actions. So this is where we define the actions. And then similarly to that, the rule group will have a payload. So I know when this record gets to that state and it's of that type, I need to go and fetch that payload template that tells me what are the items that I want in my payload. So again, everything is data-driven. So now in the next slide, I'm going to have a look at the code details. So how did we do that? This is going a little bit technical. I'm not going to show too much code, but just at a high level, we had three main projects. The payload generation that had a couple of classes. Again, there was a lot of abstraction, a lot of interfaces when you see the little I in there. So the I rule repository. So this is the rules engine. It has the I rule repository, which means that can be mocked, but we also had the Dataverse concrete implementation of that. And then the plugin is nothing but the joint between all of those. So go get me the get me the payload, get me the rules, and then execute the engine, which is in there. So separation of concern was really important. And then we looked at putting that into Visual Studio. So we had our main solution in there. Out of those solutions, we had quite a few little projects here and there. And as a result, what that generates is multiple DLLs. Now, we know that with Dynamics 365 and Dataverse, when you deploy a plugin, a customization, it has to be part of one DLL, one dynamic library. This is an existing limitation. Luckily, they resolved that, and there's a public preview currently running where you can turn that into a NuGet package and put all of those to a NuGet package and deploy them. We also had the unit test in there, but basically we used the latest feature called dependent assemblies. I was lucky enough to be part of the private preview first, and now we're using the public preview to actually compile all of that, turn it into one NuGet package, and then deploy that NuGet package into our Dataverse environment. Now, given that there was a lot of insight from the technical team, we knew exactly how the pipeline executes, and we used that to our advantage. This next picture is from CRM4, I believe, but the concept is exactly the same today. So this shows you in here that when a specific event triggers, there's a bunch of pre-event elements that happen. There's the core operation that talks to the database and persists the data. And once this is done, then there's the post-event. At first, we built it as a post-event. So once you save your record, then you go and execute the rule. But then what we realized is that that's causing a lot of double up. So if part of that pipeline execution is the same record that I need to update as an action of the rule passing or failing, then it goes and triggers the pipeline, updates the record, goes to the post-event, realizes that it needs to update the record, goes back, updates the record, and then carries on. So instead of doing that, we moved it into a pre-event, which means it comes here, it realizes it needs to update the record, it updates the record in memory, and then goes to the core action, and it takes the updated version of that, persists it, and then executes, which meant that there's a lot of actions that became 0 milliseconds to execute. and I'll show you some of those numbers. Right. So at a high level, the sequence on how it works. Plugin triggers. It goes to the Dataverse repository, gets the groups, gets the rules, goes to the payload repository, and generates the payload. So when we get to this point, we've got the rules, we've got the payloads. It calls the evaluate. So this is where the core of the engine happens. Is it less than $1,000? Is it a regular customer? So on. Comes up with the results. Based on the results, it goes, all right, what are my next actions? All right, and then it triggers those actions. This is the sequence that we used. And I'll talk about how long each one of those steps takes. Cool. From an authoring perspective, this is where the experience was not great. Given that it's mainly data-driven, we needed to understand what is the schema behind the record that we're trying to find, and we needed to type it in. Yes, in the future, we can enhance that by understanding what the schema is, using drop-downs and things like that. But for now, it was fit for purpose. And we had ways of unit testing that to ensure that we're doing the right thing. And then once that was done, then we wanted to know, all right, how do we execute the action? So we had a result type. So for example, test the action, update an attribute, create a new task, or call a Power Automate and give it some additional metadata. Again, mainly manual entry, but that was okay. All right. So next, I'm going to do a quick demo. So I'll show the rule authoring experience, and I'll also show how does the rule execute. Any questions before I go there?
At the beginning, one of the requirements was around having rule, I can't remember the term you used, but basically no auditing, no traceability on the rules, which is not how a lot of organizations want to operate. They want to know if a regulator comes along and says, why did you reject or approve that loan or that insurance payout? Can you show us? So I'm assuming that would be a relatively straightforward extension of this to track those.
So we actually, the way we address that is by using security roles.
Right.
So the auditing is there, and it's kept there for however privacy allows us to keep this information, right? And then, but it's sheltered or it's hidden from the average user that looks at the system. So they won't be able to see any traces of what executed.
Yeah.
And you're 100% right. Like sometimes an application would get rejected and the manager would go, why am I doing that manually? So they would go and request to have a look at the traceability. And we had a detailed audit of, and this was the beauty of it, is that each rule had a name, each rule item had a name. And once you looked at the log of what was executed, it was literally like showing you a branch of this executed, this failed, this passed, and so on. And it gave us a full understanding of why we went this way or that way.
And another question, sorry, in terms of the input to the rules, assuming there was also consideration done around leveraging AI models, things like propensity, stuff like that could be as an input in, potentially?
Potentially. Yes, potentially, but we didn't do that. And that's the thing, those rules are deterministic, right? So you know exactly this will happen if this, else that.
I'm trying to make it into an next best action engine.
Exactly, right.
Yeah.
And it is a potential. In fact, I can't talk about that. We've got something that checks a comparison and gives you a percentage of comparison. And based on that threshold, we say yes or no.
Yeah.
So we do things like that to a certain extent. All right. So let's have a look. What am I doing? All right. So it's a model-driven app. So hopefully many of you have seen that before. Relatively straightforward. Those are the different entities that I talked about. So the evaluation group, the evaluation rules, the evaluation items, the payload template, and the payload items. So if I go to a payload template, so this is the insurance case template that I created. I click on that. It tells me what entity is it associated with and what are the different elements that I can grab from that entity. And this is the key value pair, basically. So the way it works behind the scene is that it goes, all right, I'm executing within the context of a case. I know that a case has a customer type and a claim cost. So during the execution, it says, give me the case at hand, dot, customer type, give me the customer type, dot, claim cost, give me the claim cost.
and store them into another value. In this case, I gave them the same name, but it could be something else that is used in the payload. So again, relatively straightforward. But in terms of understanding what that is, you had to go and type it in. There's no smarts behind it. There's no validation behind it, which is a bit of a shortfall for the platform, but again, room for improvement for the future. Now, the evaluation group, I've got one that I'm mainly going to be demonstrating today, which is the insurance claim. And in there, it has 3 different rules that can trigger. The first one is that they are ordered, so 1, 2, 3. So maybe I'll put them from the smallest to the largest, because they do execute an order, and that's very important, because you want to do an if this, do that, else if this, do that, else do this. So you want the else to be the very last one that it will execute. So the first one is that if it's less than 1,000, regardless of whether you're premium or a regular customer, auto approve. Very simple. The second one is that if it's less than 5,000 and you're a premium, then auto approve. And the last one is the else, is that if it doesn't fit any of those 2 categories, then go and say that it's a manual approval. And basically, this is it at a very high level. Now, quite often we would get to specific rules, or let's say, a bunch of rule items where customers would be like, oh, I want to reuse this, I want to do that, and how can I manage that? And again, because it's data driven, we can use the platform as it is out of the box. So if I want to go and update those in bulk or create in bulk and associate them with a new rule or give it a different name, if I want to edit anything, I can just export to Excel. In fact, why am I doing export to Excel? I can open an Excel online, right? So I click on that button, and that gives me an Excel representation of my rules. And the customer loved it, because let's say they didn't like the names. I'm like, you know what? I don't care. I'm going to call those rules potato 1, potato 2, potato 3, and then I'm going to give you the keys to that Excel file to go and call it whatever you want. And they love that, because then everybody knows how to use Excel. Everybody knows how to enter the data. So they really embrace that capability. And if there was something wrong, like in here, yes, values are hard-coded. This one, for example, DXC eligibility days, is an environment variable that I'm using. So it knows that there is a value out there that I can configure to actually take that data. So they can extract it as well. And if we made mistakes, this is greater than, it should be less than, then they can go and update it themselves using the Excel spreadsheet and then fix it. And then given that all of that is data driven, then moving it from one environment is relatively easy. So now we'll get to the core of it and the demonstration of how does that work. So I created a couple today. So let's put the newest first. So here are the 2. So the first one is that we've got a premium customer with $3,000 as a claim, and the other one is a regular customer with $12,000. So we'd expect the first one to auto approve and the second one to not auto approve and create an approval task. So I go there, and this is the state of the record. Again, it's going to look at customer type and claim cost. So this morning, I think, was it Bernie or Lynn that was talking about the level up? So this is the level up add-on to Chrome. And I can do things like, show me the logical name of the fields. So when I click on that, you can see that this specific one in here is the claim cost that I talked about earlier, and this is the customer type. So those are the schema names associated with it. So very simple to do. And the trigger is if I say evaluate. So if I change that to a yes, let's refresh it for now, before we trigger that. If I say evaluate to yes, and then click on the save button, then this is the engine now being called behind the scenes. First time it takes a little bit of time to execute, but it's auto approved, and that's it. Like there was a little bit of delay, but that's it. That's what the engine does. In all honesty, it's a bit anticlimactic, when you see how it's working. But if you think about how much time and effort did it save us, that's the important thing. And the fact that it's anticlimactic is also the point, because it actually did exactly what you wanted to do. So the next record is that we've got a customer asking for a $12,000 claim, who's a normal customer. So if I say evaluate to that one, then again, that engine will work. As you can see, it was much faster now. And then what it did is it turned it into a manual approval. It did not deactivate the record, and it asked us, it created a new task in here, which requires manual approval, which then will be passed into the manager to go and have a look at it and so on. So relatively simple, relatively straightforward. Again, anticlimactic. Now, put all of that into a series of rules that have to execute. So one of the implementations that we did required 24 rules to go end to end. We could manage to finish this whole thing in 12 seconds. So someone clicks submit, and then automatically triggers the first rule, goes through the first stage, second stage, all the way to the 24 rules that it needs to execute. Each rule takes about half a second to execute, and it gives you all the information. And that was phenomenal in terms of how quickly we can execute that and how easy we can use the platform to our advantage to do all of that. So the last section of the presentation is to talk about the unit testing that we've done. Any questions before I go to unit testing? Yeah.
So what do you do with it? You said that it's all this.
Yeah. Technical, that was out of scope.
Okay.
But that's a good question. And it's a question that doesn't only go with rules in general, but with Fusion development, you tend to have an old, ugly way of doing things. And then you come up with a better, more streamlined approach to do things. What is the best way forward? So everything old becomes technical debt. But for all purposes and intent, if it's working, if it's not broken, don't fix it, right? So if it's doing what it's supposed to do, we keep it as is. The moment we touch it or we think that it needs to be enhanced, at that stage, we migrate it to the new one. Because keep in mind that migration to the new environments requires a lot of testing and verifications and so on, which is not very straightforward. So we need to be careful about that. But yeah, existing ones we didn't change. Anything new we used using that platform. All right, so from a unit testing perspective, we could run, each one of those tests is actually leveraging, I don't think I have a screenshot of that, but each one of those tests is fed through CSV files, right? So those are typical unit tests in C#, and they get the data from a CSV file. So in each one of them, although it looks like it's just one execution, has on average about 8 tests that it's executing. So we're talking about less than 2 milliseconds per test. So we've got thousands of different permutations that you want to check on hundreds of rules. You can do that in milliseconds. And that really becomes a powerful story to see how we need to do that. Be it in an insurance environment, Annie and Kiri, whether it's a citizenship eligibility, whether it's a passport eligibility, whether it's a visa eligibility, all of that can be fed into the CSV file and tested. And the good thing is that, as I said, the data can either be straight into Dataverse or the data can come from a file. So what we ended up doing to get those really fast values, before we run the test, we would do an extract of the latest changes we've done to all the tests. And we use the Fetch XML part of the, what is it called? Fetch XML Builder, Fetch XML Builder, part of the XRM toolbox. Awesome tool to use. And it allows us to turn all of that data that we have into another CSV file that we then loaded during in memory at the beginning of this call. So that's why you would see that the first one would take maybe 3 seconds. That's because it's reading a big CSV file, turning everything into memory, and then executing all those rules sequentially, which means we didn't need any connection to Dataverse. But we can then deploy to test and run that test on Dataverse rather than on a CSV file, and then double check that the deployment went smoothly. Probably will take a little bit longer because it has database connection and it's going to the cloud, but still just a validation step. And again, given that the separation of responsibilities, that became really good to do. And then Microsoft Fast Track got involved. And then they said, customization. Ooh, this is going to be very slow. You guys need to do stress testing and performance testing and so on. I'm like, okay, let's put it to the test and let's have a look at it. And this is the same sequence diagram that we had. I ran 1,200 rules within an hour, and I collected the single execution of each one of those methods and put them into a table. And in a nutshell, anything to do with reads was about the 50 millisecond. So read the groups, read the rules, generate the payload, and then get the actions. Most of those were actually just querying, like select statement if you want, around the 50 milliseconds, maybe a little bit more. relatively fast, basically. Anything that executed within that business logic, remember we had the core of the engine, and that was the business logic in the middle that takes data from one area, takes data from the other area. So the data is already there. We're feeding it into the engine, and we're saying, engine, do your best. Go and figure out whether there's a match or not. 0 milliseconds. Because all of that executes in memory, right? When I was doing it on my laptop, I had 1 or 2 milliseconds. I'm like, yeah, it's okay. Maybe I can enhance it or something like that. But because this is executing in Microsoft clouds where they've got like supercomputers and whatnot, anything that is in memory is super fast. So I was really impressed to see that. Now, the thing is that the actions were the slowest. And that's because the actions either call custom connectors that go somewhere else, or they go and create new records and tables, which is also a costly operation. But all in all, you know, we had a plugin execute in less than 500, maybe 600 milliseconds, which was really great and really acceptable in terms of performance. The rule of thumb is that it should be around the 400, 600 milliseconds, which we had, but most importantly, should not exceed 1,020 seconds. So 2 minutes is the timeout for a plugin. We were way far from that. So that was great for us. And basically, yeah, we're in the process of actually working on that, enhancing it. The environment that I showed you is something that we built maybe 4 months ago, and now the engine is done, is ready. You know, we're just feeding it data and just building those rules and all of that. So the customization process is over. And I must say, like personally, it was really satisfying working on it because I'm a developer. I have a background of a developer, and I loved just getting my hands dirty and then doing all of that work. And to the point where, you know, I was on the train, and because I've done that for so long, I don't need the internet to figure out how to code, right? So I can just, you know, switch on my laptop and then start working in Visual Studio. All of that was mainly done offline because I can build those classes offline. So I would go on a train and I would spend 45 minutes, you know, doing that. And whenever I'm not taking the train, I'm like, oh, bummer, I can't do that at work. And then sometimes I will be awake till 2 a.m. in the morning. It's like, oh, I just want to finish that one and just make sure that it is working. And once it was there, then the rest of the team, I handed over to the team and I'm like, okay, you guys extend it. And they were excited about it. They were engaged. They were doing what they love doing as opposed to, you know, click configuration. So it's really good story in terms of keeping the entire team engaged, in terms of doing things more efficiently and sometimes challenging the customer and going, maybe we shouldn't go all the way low code, no code. Let's introduce a little bit of customization so that we can have better efficiency. And then with the testing, you know, productivity we got, with the assurance that the rules will work and so on, it was a win situation. And that's it for my presentation. Any questions? But you can download it if you want to. No, not yet. but that's something that I'm considering is open sourcing it, is putting it out there for the community, because like every time I go to a customer, and I know I've talked with a few MVPs about that, going, hey, you know, it would be really good if we can do it as a framework. And then I got the opportunity to do it, and I built it. And I'm like, yeah, the vision did work. So yeah, maybe one day we'll open source it.
Or Microsoft put it as part of the Power Apps platform.
Yeah, it's that's an interesting topic because I'm working with a few product managers at Microsoft and talking about not really, you know, turning that into a part of their platform, but in terms of how can we do things better. And I think one of the answers is PowerFX. PowerFX is really making its way through the platform, and it is that low-code, sort of no-code platform. And the thing that it's missing right now is the reusability aspect, is to say, I've got a rule in there, it's really easy to configure, it's data-driven, I just want to put it in here and there and there and there. Then it becomes easier.
I think the difference here is that is a rules engine where you have a centralized hub of all your rules. So from a maintenance point of view, fantastic, right? And you could improve the usability and whatever else that you say at any point. But it's definitely something that is missing from Dynamics and Power Platform in general that I've noticed. So I've been exploring it myself. So it's good someone built.
Yep, sounds good. Sounds good.
You know,
Yep.
this is a question. So
So this is a scenario you want to reuse the plugin. And if you want to reuse the plugin, you just enter a data that's exactly that.
Yeah, that's actually a very interesting question. How did we make it generic? So the plugin itself, as I said, the rules engine itself doesn't know about the schema. It only needs one field, and I'll show you that. So if you look at my case, and if I go show me the schema, right? So all it needs is to make sure that you've got one field called, in my case, DXE evaluate, right? The plugin triggers. The plugin doesn't necessarily know that it's triggering for a case. All it knows is that there's an entity in there that has something called DXE evaluate. And then it goes, all right, I know I have to evaluate now. What type of entity are you? You're a case. Okay. Rule group. Is there something associated with case? Template. Is there something associated with case? All right, give me this information, generate the payload, generate the rules, put them in the engine, and come out. So again, the engine is not aware of that. It's done at runtime when it executes. That's one thing. The other thing is that the way we do it is that all you have to do is just go register that plugin to that entity on update of the DXE evaluate. So there's one manual step where you have to link the two together, that's all. But that's at registration time using the plugin registration tool. Makes it a bit easier. Yeah.
How did you get the customer, like the customer at the beginning was saying low code and way? How did the conversation go to actually get them off that and accept customization?
Lesson learned. So as I said, sometimes you start from scratch and you learn from that mistake. Sometimes you inherit from someone, and it's easier to point the finger and say, "Oh, look." So they had Power Automate, and they knew that whatever they did, part of the initial implementation, was not scalable, was not maintainable, and they were looking at options, right? And one of those options was, as it typically is with customers, they would say, number one, out of the box. Number two, buy something off the shelf. Number three, customization. So customization is always the last one. And that's why at the beginning of the session, I talked about doing your analysis. So we looked at our off-the-shelf products and we said, it's going to cost you a lot of money. And also, it's not going to do exactly what you want. Whereas with this, we've got full control over it because we're building it. And also, the others have vulnerabilities, they have issues, they have defects. You're at the mercy of the other vendor, and introducing another architectural component into the mix is also going to be risky. So we had enough validation to say whatever is existing using low code, no code doesn't work. If you want to carry on that way, we can do it, but we can guarantee you it's going to be a maintenance nightmare. Off the shelf, yeah, maybe, but then this is another kettle of fish, and it's also expensive to get on board and then get, even for us, like to understand how to use Node 52. I've never used it before, right? I need to upskill them and so on. And then all of that led us to, hey, how about we have a look at that? And that went through a couple of rounds of proof of concept and making sure everything is okay before we actually finally got the thumbs up. Yeah, so there was a process. Anyway, thank you very much for attending.